Construction workers in the real world build things. You give, let's say, a construction worker some blueprints and they will construct or build something like a building or a car or a plane or anything else that requires a blueprint. So likewise, what are these constructors in programming? Well, these constructors in programming are in fact like construction workers. Now, in the case of JavaScript, we have constructor functions. This is the typical way that you create objects in JavaScript. But why do you need a constructor function? Why do you need a blueprint to create an object? Well, we may have, let's say, a game, and we have a player, and the player is an object. We can describe him, and he has certain characteristics, and this player goes through the map, and he comes in contact with apples. And when he touches an apple, he gets more points. So we want to have a constructor function for all of the apple objects that we want to construct throughout our entire program. So we need to be able to create a constructor function so that our program can call upon this function dynamically and create an object from it. And when we create an object or an instance, that's all it means. An instance just means a copy of. It's a copy of the blueprint. Kind of like me having a blueprint for a building, and what we do is we copy that blueprint over and over and over again. We create an instance of the blueprint. And likewise, we're creating many objects from this constructor function. So that's why we have constructor functions. So our program can call upon this function at any time. A user clicks a button, it can generate an object, for example. A user goes to a new level, we can randomly generate more apples. There could be many instances of why we do. If you were creating a graphics editor, for example, and you import an image, I need a basic blueprint of data for that image to go into my main data store. I need to keep track of all of the images the user is importing into my program. Whatever it is, you're going to need some means of construction. So that is why we have constructor functions. So first of all, I want to create a constructor function for the apples that are going to be produced throughout our game. So I'm going to create a function, which is a callable object, and I'm going to call it apple. Now with the naming of your constructor functions, please add in a capital letter to begin with. And the reason why we do this is because it helps us identify that this is a constructor function. Whereas if it was lowercase, it kind of just looks like every other function. It's just a naming convention. You don't have to do it with your constructors, but it's ideal to actually have a capital letter with a constructor function. Then we can pass in some parameters. Now we're creating a template here for our apples, but our apples can be placed at different positions. They can be a different color, and they can provide a different score to the user. So even though we're constructing a single apple object from this constructor, the values are going to be different. I'm not just going to create a flat object and then they can change it later. What I want to do is I want them to be able to create objects on the fly that have different values. It's the same template, but it's got different values. So for example, X, Y, we need these parameters. We also need the color, and we also need the score as well. Now what we need to do is take a look at this execution context and of course the context of this. Now you know when you actually invoke a function, that is how you determine this context, the context of this execution context. So with constructor functions, you use the new keyword and then you invoke your constructor function. Why? Because we don't want this by default, if you were to just call it like that, to equal the window object. That's bad. We want to make sure that we assign a new context, a new object context to this execution context, like so. And then we start adding in, let's say, properties and values and methods into this, whatever you want to do. It's just like referring to an object. So for example, let's go ahead and say this dot. And so what I'm doing is I'm referring to this new object that I've assigned to this keyword because of how I've invoked the constructor. So when I'm using dot, I'm accessing an object. This contains an empty object. A new object, if you will. And I can say, right, give me the X position, and that's going to be equal to X, for example. there'll be a value assigned to X, like so, maybe the value of 10 or something like that, and that value will get assigned to the object's X symbol. So if I say X10, that's what we're doing here. So please do note the difference. This is the parameter pointer, and this is the symbol contained within the object. Be very, very careful. This is the symbol pointer within the object, and this is the symbol pointer for the parameter. So there we go. That's all this is doing. This is just an object now. It's just a new object that I can manipulate and play with. So you've got Y, you've also got color, and then also you've got score. And all that's going to do is it's going to return the object. Now you can say return this if you really wanted to. But to be honest with you, the context, it doesn't make sense, because once we actually start invoking this execution context, there's no need to say it. It will by default return whatever sort of the value is in this function. So actually we don't need to say return this. It's just going to take a look at the context, the current value, and the current value is this object that we keep manipulating. And if we keep manipulating it, all it's going to do is it's just going to return this object wherever we invoke the function. And it's going to invoke it with, and it's going to return with all of the values we assign. So let's go ahead and add in some arguments for our parameters. So for example, 10, and then we've got 20 on the y-axis, and the color is going to be red, and this one is going to give you 200 points. Now, if I was to just save this and hit refresh, you wouldn't see anything in the console. You can log it out to the console, for example. You could just copy this and paste it in the console, and you'd see that it does return an Apple object. You'll notice it has the name of the constructor function, which is here, and then it tells you what it returned. Well, it returned an object with the X is 10, Y 20, color red, and score 200, just like the values we've passed in here. Well, that's no problem. But there is a little bit of an issue. Once you create this object here, like that, so it returns that object. Perfect. How can my program later on reference this object? It can't. Because there's no way for me to reference, there's no symbol name to target that object in memory. So what you actually need to do is make sure that when you invoke it, you assign it a symbol name. So I'm going to say var apple1. And then when you invoke the function, it's going to return an object, and you can point to that object later on in your program using apple1. So I'm going to now save that out, hit refresh, and say apple1. There is apple1 with our defined values. And then you can start creating more instances, meaning more copies of this object. And they can all have different values. Each instance is independent from one another. So for example, this will return an object that's going to have these values. So I can just copy and paste that in. So we can have that, and you can have another one, and then you can have another one. They could all be identical if you really wanted to, but then you can start to change the values even then later on. Because each one is an instance. It is a copy of. We created this object from one function, but each instance, each object is unique. Just like, for example, you can have a MacBook that's identical to another MacBook, but one MacBook goes to another user and another MacBook goes to a different user. And you can change that MacBook, you can reinstall it, you can do different things to it. They're all objects. So even though they come from one factory, one construction house, if you will, or place, then you take that and then you can change each one independently of one another. It's the same thing here. Just think of this as the production line, making objects, then you've got each object, then you can keep changing the objects. What will happen is you will get different instances. We now have 3 Apple objects, and we're passing in different values. We're constructing that object each and every time off the same blueprint or constructor function. And there you go. Just hit refresh. Apple1. Apple 2, and Apple 3. And that's it. You now have Apple 1 with its own set of values, and each one has its own values, whether it be red, green, or pink. And it has a different score, 250 or 10, and so forth. So you just keep going in this fashion where you construct objects, and that's all you're doing. You're just creating, in essence, a manufacturing line. You are creating a place where you are defining the blueprint of an object. And yes, each object can have different values, but it has the same structure, if you will. And yes, you can even modify the structure if you wanted to, which we'll talk about later. But overall, you're just creating objects from constructor functions, and your program can actually invoke this function by itself. So it can mathematically map out where it wants to place these apples, and then it can call upon this constructor function when it needs to and keep generating more apple objects.